Yeah, so welcome back to Object-Oriented Programming 1. We are now starting with the first actual lecture with an introduction to C++. I'm here together with Lukas.
Hi.
And we will now take the big step from C to the basics of C++. So, when we take a look at the differences and compare C and C++, we will observe definitely a lot of similarities, but also some differences. The first and maybe most obvious difference is that we don't call the files, for example, main.c anymore, but we call them main.cpp or any other file name .cpp. So whenever you write a program in C++, we now have to create a CPP file, write our code in that, and then compile and execute this code. Another difference is the compilation of the code. In C, we used Clang. In C++, we now use, again, quite obvious, but Clang++, for example. Of course, there are different and other compilers, but in the lecture and in the practicals, we will use Clang++. What we've used in C is also the include directive, for example, for printing something, for scanning something. We used include stdio.h. Similar, in C++, we again use include directive, but we just write IOStream, so we don't need the .h anymore. And also the naming is a bit different. But essentially, these two include directives are used to, for example, print something or scan something, read something. The next and probably very important differences between C and C++ is printing something, for example, to the console, and reading something. When we, for example, printed something in C, we used the function printf. Then we had some string in there, maybe even some format specifier, and then we could print something to the console. In C++, we don't do this anymore. We now have the output stream, and we write this as std. Then, looks a bit strange the first place, but then we have these two colons followed by cout. So this is the equivalent in C++ to printf in C. Whenever you want to print something to the console, we now use std cout. And the last, let's say the last difference here on the slide, of course there are many other differences, is reading, for example, from the console. In C we used scanf, then we had again some strings, some format specifier to read something, and we also had the variable that should read the value. And in C++, this is quite similar to printf and std cout. Now we call this std cin.
Yeah, and as you will see on the next slide, this cout and cin will make life much easier compared to printf and scanf, but we'll come to that.
Definitely, yes. And similar to what we have done in Introduction to Structured Programming, we now want to write our very first program in C++, and of course, what else could it be? It's a Hello World program. For this, let's take a look at this piece of code here. I hope it's large enough that you can read it. And if you wanted to do that in C, we would have written printf, hello world, then maybe \n, and this would be the C version. Now that we can use std cout, for example, we can just write std, then these fancy double colon, cout, and we just write hello world. Let's skip the \n or std endline at the moment. Compile this, and we will see.
Yeah, what is also new is this operator between std_cout and the string that we provide here, but we'll explain that later on in the lecture part.
It's a bit of a different syntax, but in general, this just means that we want to write this part here to the output stream, and this is then printed to the console. So when we execute our first Hello World program, we hopefully will see Hello World. Very good, nice. We have now written our very first C++ program.
I see something missing compared to the C version, the new line.
Yeah, we could, for example, we could try this. So let's see, does this work? Yes, looks nice.
Okay, but is there maybe a nicer solution for this?
Yes, there is a nice solution in C++. And so we don't write the \n anymore into the string, but we add another part here when we print something, which is called std endline. We'll see later why we should always use std endline instead of \n. Of course, both work, both are totally fine, but std endline has some advantages. And let's save this, compile it again, and we will see the same. Nice.
Great.
Very good. So this is the very first program in C++ that we have written. Now we want to also highlight again these two operators here. These are called output stream operators. This means that these parts here are streamed here to the output, and cout has the functionality to print it to the console in this case. So we don't have to write the parentheses anymore like in when we use printf, but we just write the output operators, and we can add here, for example, another string. And this would just print all three parts here. So hello world, OOP1, and the end line, the new line. So this is very nice for having multiple parts and printing them all together in one statement.
Cool thing is that we can also, except from strings, we can also concatenate, for example, integers here with strings, but we will also see that later on.
Let's try it. It's a bad naming, but just to showcase that this works, we can just add I here, compile it, and we have, again, hello world OOP1. So that's quite nice for also printing, as I said, variables.
So no need for format specifiers here, but we can, then work here with this output, with these output operators and the cout in a nicer way than with the printf, as we know from C.
Okay, now we had a look at the output stream operators. Now we can also take a look at std_cin, which means we read something from the console, for example, and write what has been written into the variable, for example, this integer variable here. So in C, this would be a printf, this here would be a scanf, and this again would be a printf. And particularly here in this line, we don't need the scanf anymore. We just write std_cin. Then these two characters here are the input stream operators. So if they go to the left, they are called the output stream operators. If they go to the right, they are the input stream operators. And with that, we can just read any value, store it in a variable, and use it in our program. Now let's take a look at enums and structs. We know enums and structs already from C, from Introduction to Structured Programming, and we've used them. They were quite helpful, useful. But a very nice thing here is that we don't need the type def anymore. So in C, it was always a bit cumbersome to write type def struct, then the name, and then again the name. We don't need this anymore in C++. We can just write enum and then the actual name, or struct and the actual name. So that's a bit more beautiful to read, I would say, and also to write the code that we could get rid of the type def. Another difference, or actually just a syntactical difference, is the use of null and null pointer in C++. So in C, we used null, which is just a macro, and this macro just means 0, or more precisely, it's void pointer 0. And in C++, we have the null pointer object, or this keyword here, exclusively for pointers. So that's really nice, because now we have a difference between the actual value of 0, which is essentially the null keyword in, or the null macro in C. So we have a difference between 0 and null pointer as a value. So that's the huge difference here. Null translates to 0, or void 0, void pointer 0, and null pointer is again something different. So we can distinguish between 0 as a value, which would be null, and null pointer. That's a nice opportunity to, for example, catch something that is a null pointer but not 0. So that's really useful, and we will also use that in the practicals, but also we will use it in examples in the lecture and practicals. All right, so we have now made the huge step from C to C++, and now we want to introduce the first C++ specific concept. We haven't heard of that, and we haven't used namespaces in C before. And we will now show why namespaces are quite useful, why they are helpful, why they are used heavily in C++. Because, we are now getting into the field of object-oriented programming, so there might be a large code base, and we want to organize, we want to structure our code. Otherwise, it would be quite impossible to read and understand what has been written. So, let's take a look at namespaces. Let's assume we have a struct, which is called superhero, and we want to have another struct, superhero. If we wanted to do this, for example, in C, the compiler would say, no, you're not allowed. Why do you want to have two structs with the same name? So both are called superhero. Why do you need this? This doesn't work. You're not allowed to have two structs with the same name.
Although the members are different, because we have one on the first one has strength and the second one has weakness at the end, but the name of the struct is the same, and this does not work, obviously.
Let's assume we want to have two superheroes, one for Marvel, one for DC. I'm not sure if you're familiar with the superheroes.
Just from our slides from last year, but yeah.
I'm also not familiar with them, but why don't we want to have superheroes of both worlds? Would be nice, right?
Yeah.
And just by declaring these two structs, we cannot achieve that. If you want to have both superheroes from the Marvel world, but also from the DC world, we would have to use namespaces. So we can define a namespace for Marvel. We have a struct inside of this namespace, which is used then for creating the actual superheroes. I don't want to mention any name because it's definitely wrong. of course, we can also have a second namespace or even a third namespace that has the same struct or a struct that has the same name. Could be the same fields here, could be different fields, doesn't matter. It's important that they have the same name, but they are in a different namespace. And this is totally fine in C++. We can do that. We can have 2 namespaces, we can have 10 namespaces. Can be all the same name for the structs. This is totally fine in C++.
Now they are separated, but how can we access them now?
That's a very good point, and maybe this also answers some questions that might have arisen when we first used, for example, std : cout or std cin. We can now use the double colon operator, so we can use the namespace access operator here. We just write the namespace, so for example, Marvel or DC, followed by this operator here, by colon, and then we write the name of the struct, which is called superhero in both cases, and then, just a identifier, just a variable name. And by writing the namespace here before the superhero, we can now distinguish between the Marvel superheroes that should be created and the DC superheroes that could be created. So we have 2 superheroes here using the same name of the struct, but using a different namespace. And this is totally fine in C++. This is actually quite often the case that we have actually naming conflicts, but just having same names in different namespaces is totally fine. And that's why also namespaces are definitely useful, for example, for larger code bases where naming conflicts, naming clashes can definitely appear.
Mm-hmm. Yep. But keep in mind that it could get annoying if you have multiple levels, so-called nested namespace. As we show you here, you have, for example, a company, a department, a team, and so on and so forth. And if you then want to use those namespaces, you might, have a problem writing this down always, and this makes your code, the readability of the code gets worse.
Yeah, absolutely. So we have 3 different namespaces here, just to have an integer variable. And to access this integer variable, we have to go all the way from the first namespace company to the second namespace department, third namespace team, until we finally reach the employee ID. So yeah, they are quite useful, but they can also be annoying, especially, as you've mentioned, Lucas, if they are nested, if you have multiple levels of namespaces. We have one option to make this maybe a bit easier. So we could use, for example, a directive called using. If you use the using directive, you don't have to write the namespace anymore before in this case, the struct or any object that is inside the namespace, but you can just write the name of the object of, in this case, the struct superhero. So we can get rid of this Marvel and then the double colon, and we just write superhero Iron Man. Because when using the using directive, the compiler will know, okay, superhero belongs to this namespace Marvel here. And that's why we can just omit this part here. Mm-hmm. Of course, if you want to create a superhero from the DC world, we have to write the namespace DC here. Otherwise, the compiler would assume, okay, this is a superhero from the Marvel world, and we can create a superhero from the Marvel world. So we have to explicitly use the namespace if we want to use the superhero from DC in this case. So using is quite nice, but we should also be a bit careful about using the using directive. For example, all the standard library objects or functions are in the std, in the standard namespace. So we'll also see this later when we introduce other C++ functionalities features. They are all in the std namespace. So you will always need std, : and then whatever object you have, for example, cout, endline, cin, and any other object. So, since everything is in the std namespace.
Could we then just say using std for avoiding then writing it all the time?
Maybe I can forward this question.
What do you think? So
what do you think?
Can we just write using std, and then from this time on we can just always write cout, endl, cin? What do you think? Yeah, that's correct. So we could do this.
Do you think this is a good idea? All right, anyone else? Is it a good idea to write using namespace std? Yes.
We don't know if we have any conflicts or variables with the std library. So there could be clashes if we name our variable handle.
Yeah, you're absolutely right. It's definitely not a good idea to use the using directive, using namespace std, because you might. There are so many objects in the std namespace that you simply don't know if this might lead to a naming conflict. So if it leads to ambiguity.
Yeah. So for the Marvel example, because we wrote this code, so we know that there's just this superhero struct inside. But if we use it for the std namespace, we then maybe don't know all the things we can use inside this namespace, and then there could be some ambiguities, so Doppeldeutigkeiten in German. So please don't do this for std.
Yeah, this could lead to some problems, to some troubles, and you can take, or it can take a long time to find bugs, which is introduced by this. If we, I'm sorry, I'm not sure if I got this right. If you,
so that,
yeah, I think it compiles, but we don't know which version will be used. We would have to try this. Mm-hmm. We can take a look at it, and
maybe this is something for the practicals where we can try this out. Or you can try it out on your own.
Yeah.
But however, you should not do this. Yeah.
But as far as I know, I think it compiles at least. Mm-hmm. But we don't know which one is used.
Which makes it even worse to find bugs then. Yeah.
Okay. So please do not use using namespace std. But we could also use the using directive for specific commands for specific objects. So instead of using namespace std, we could just write using std cout, for example. And this now would work to just write cout instead of std cout here. And okay, it's a bit shorter and a bit more efficient to write. And usually we know that cout is a command, is an object from the std namespace, and we usually don't name a variable or anything, any object, cout.
And for all the other things in the std namespace, we would have to write std again.
Yeah, exactly. So if we, for example, use cin here, we would have to write std cin. So the using directive here is only for the two objects cout and endline. And now we can also discuss the difference between std endline and \n. And yeah, the main advantage of std endline is that we can use this even if the program crashes, the buffer is flushed. So, for example, you have some output in your code, the program crashes, std endline will make sure that the endline is actually printed, which is not the case when you use \n. So, for example, if your program crashes while printing something, for example, it is not guaranteed that the \n is also printed. So that's the main difference between std endline and \n. So I would always suggest to use std endline. All right, now we come to the next concept, and yeah, it's not an auto, but it's a keyword or something specific that we can use in C++. Would be nice if it would be that auto, but yeah. If you want to create a variable, let's take this x is 5. We just write the data type, the variable name, and some value. So that's what we have also done in C, for example. So we as programmers, as hopefully human, decide what is the data type of this variable. So we explicitly write if it's an integer, if it's a character, if it's a long, double, boolean, whatever. But in C++, we could also use another data type by using or use the keyword auto. And when we use this keyword, the compiler will decide what is the data type of this variable. So let's take a look at this snippet here. We have int x is 5. And if we now want to assign, for example, the variable x to another variable, and we, whatever might be the reason, don't know the data type of x, we can just write auto y is x. And the compiler will infer that, okay, integer x, so the variable x is an integer, now also the variable y will be handled as an integer internally. But we as programmers don't have to write the data type anymore. Explicitly, we can just write auto and the rest will be handled by the compiler. Of course, this not only works for integer, but also for character, pointers or strings, and also for float or double values.
So does this mean that we can from now on just always write auto?
We could do this. It would to some extent work, but of course, that's not really a good idea. Do you have any suggestions why this is not a good idea to always write auto? Yes.
Sometimes you want to use short or long or something like that. If you have some function that returns a type that is longer than my screen, then of course it's auto, but not for any numbers.
Yeah, exactly. So we as programmers usually or hopefully know the context of a variable. So for what it is used, if we just want to have values from, for example, characters 0 to 255, if you want to have a long data type. So we as programmers usually know what is the purpose of this variable. And the compiler simply doesn't know that, usually.
And also our code might be difficult to read if we always use auto, because then we don't know at the first glance, if we have a look at our code, which data type is it, and then we have check it. So, yeah.
Yeah, especially if this applies to code that was not written by myself, for example. So imagine you're working in a group and you should extend some code that already exists and was written by someone else. And if the person that has written the code would have always used auto, I think this would be quite hard to read.
Yeah, so when should we then use auto?
If you, for example, we will also introduce this later, if you have, for example, more complex or let's say longer data types that are not used for any particular logic, but for example, only for printing something, and you want to iterate over this, this would be a wonderful use case for the auto keyword. So we will see this later. But if you have a data type that consists of multiple different data types, for example, some array or list, we'll see that later, and we just want to print this, for example, this would be a perfect use case for auto because we don't want to do anything else with this variable except printing it. And yeah, we've already mentioned the problems that can arise when using auto. We don't know the context of the variable, so if there is a specific intent of using a short or a long, and also the code is quite hard to read, at least in the first moments. Nice. So we have now took a look at namespaces at auto, and now we come to a, in my opinion, very nice feature of C++. I like it very much. It's one thing I miss in C because also many other programming languages support range-based for loops. And if we take a look at this C-like loop, for example, and we just want to print all the elements in an array, so in this case from 1 to 5, in C we would usually write int and then some variable 0. It should be smaller than the length of the array, in this case smaller than 5, and we just increment this counter variable. We print this variable using here stdcout, stdendline, and that's what we would have done in C, for example. But C++ offers now a great opportunity to get rid of this part here, and instead of having these 3 different expressions here, we can just write int and then some variable name, and then the colon operator and array. So what is happening here is that int I is assigned 1 value per loop iteration. So when we enter this loop here, the first element of the array is assigned to I, and we can then just use the variable I. So this is not the index anymore, but the actual value that is stored in the array, and we can print it, we can do whatever we want. In the second iteration, the value 2, so the second value is assigned to I. Then we can again print it, and so on. In the third iteration, the third element is assigned to I, and so on. In the fourth iteration, the fourth element is assigned until we reach the last element of the array. Then this value here is assigned to I, and we can print it.
Yeah. So maybe you have spotted it. There is one disadvantage for the range-based loop. So we do not have the counter anymore. So we do not know how many items left, how many items we already have printed. In the C-like for loop, we already know our counter because our counter is stored in the variable I, which we could use for some logic. This is not possible for the range-based loop. There we would have to introduce a separate counter. Then it doesn't really make sense to use the range-based loop because then we could go back to the C-like for loop. But if we want to print a whole array from the first to the last element, then this is the nicer solution from now on.
So it really depends on the use case. If we want to just print everything, or if you want to compute something where we need the index, then we would still use the C-like loop. But yeah, just printing or summing all the elements and storing it in a value, we could use the range-based loop here.
Any errors spotted here? Yes. Yes, correct. So this is, maybe because of space reasons, the output is a bit different because we have an std end line after each number. So normally each number should be in a separate line. Yeah.
That's true, yeah.
Okay.
All right. Yeah, with that we have now learned about 3 nice features, functionalities of C++. And another one that I, again, really like are references.
This is also a huge advantage compared to what we have on opportunities in C. So now we come to references. This is a new concept that we can use in C++. And we start here with an example using a classic pointer as we have learned it in C. So for example, we have an integer variable x, and then we have an integer pointer. And we assign the address of our variable x to this pointer, and then we can use this pointer by for example, dereferencing it to access the value of x. And so we can, for example, print with cout the value of x with our integer pointer. So nothing new so far. This also works in C++, but for such cases, we could from now on use references. So the difference now is that we have here this reference operator. So we use this symbol here to say that this ref here is a reference, and we assign x to it. And this means that ref is not a new variable, but it's just an alias to our variable x. So we now have 2 names for one similar variable. So in our memory, there's just one variable x, and we have just 2 different names available for it. And we can use x, and we can also use ref as if it would be a separate variable. So,
but I think what you have just mentioned is really important, that we have just one memory location in which the value 10 is stored, but we don't have a separate memory location for the second variable ref here. So in comparison to the pointers that we have used, which are again stored somewhere, we don't need this here. We just have 2 variables and 1 memory location.
Yeah. So as I've mentioned, the ref is now just a reference, just an alias to the other variable. And why this is so cool now is, as we can see in the next example, here with the classic pointer option, we would have to, for example, dereference the pointer, and then we could say, for example, ++ if we want to modify the value of x through the pointer. And if we would then, for example, access x, for sure it has changed to 11 because we have incremented it through our pointer. And with references, it's now much easier because we can just say ref ++ as if it would have been a separate variable. And if we access x, then for sure it's also incremented because it's just one variable with 2 names. This is just one simple example for references, but it gets even better. So if we just recap the concept of call by value. So this was the case when we, for example, have an integer variable x and we pass x to a function increment in this case, then the value of x is copied to this parameter here, and then if we, for example, change this value number here in this increment function, then our original x here is unchanged. So yeah, the output would be 10 because x is passed here, copied here, called by value. It is changed here, but this is a different variable, and our origin x is unchanged. With call by reference, if we use pointers, for example, we can pass the address of x to the increment function, take it here as an integer pointer, and if we dereference the pointer, we come to the original x. If we then change it, for sure, the original x is also changed, so to speak. So now the output is 11. With references, it's much easier again because we start here similar to the call by value version. So we just pass x here to our increment function. And the only difference here is that our parameter in the increment function is now here a reference, meaning that we do not copy the value of x to this separate variable, but that this number here is just a reference to this variable. So now we just have only one single variable here, and if we change number here, it changes our one variable, which is here again the same as x. So if we then come back to the main function and x as x, it is changed as well. So this is the much nicer solution now compared to using pointers, because it's much easier and we can use those references, yeah, as if they would be separate variables.
Are there any questions to this example here? Is there anything unclear? Because we will use references quite a lot, also in the upcoming lectures and practicals, but also in the assignments. Yes, there's one question. If there is an example where we could, yeah, sorry.
Could I solve every problem with pointers, or is there an example which could only be solved by references?
Is there an example that could only be solved by references, not by pointers? I don't think so. No.
I don't think so, because you can use both ways for, I think, each solution, so each problem, and both work, but the one is easier to read and easier to write.
The only thing where you could use pointers is range-based loops, actually. Because can you use pointers in range-based loops? So if you're iterating over something that contains very large chunks of memory that you don't want to copy all the time.
That's a good point, yeah. So yeah, this is definitely one use case for references where we should definitely use them. I'm not sure if we could use pointers for range-based loops.
Also not sure, but I'm not sure whether I can imagine one use case for that, but
also not sure about that. We can try it, or if you want to, you can try it. If this works, I'm not sure if you can use pointers, so for dereferencing them and assigning them to for each loop.
I'm not sure,
It's an interesting question. We will try this.
Okay, to sum the references up, use this reference operator instead of the pointer operator to dereference a pointer, for example. And references are not pointers. So references are not separately stored somewhere as pointers. They store the address of another location, but references don't. So this is just a separate naming, but there's no memory, no separate memory used. So it's just an alias, as we've just mentioned before, to existing variables. And so they can also not be null pointers because they are just, for example, integer references. So they always have an integer value. And pointers for sure could be null pointers. So depending on the use case, if you want to also have null pointers for null pointer checks and so on, you should for sure use pointers. But if you don't need it, you can use references. Okay, then we come to our first Slido quiz for today, but there's another question up there. Yes?
If I look at the address of the reference, I get the address of the variable? Or can I look at the address of the variable?
They both, that's a bad wording, but they point to the same memory location, yeah. But they are just variables as they are. So the variable itself is not somewhere stored in the memory. It's just aliased, as you said, and they would have the same memory location if we go like that, yeah.
Okay, what is the output of this code snippet? So we have a main function below, and on top we have an increment function taking different types of parameters, different data types. And then we have some integer variables in the main, passing them somehow to this increment function, and then we print x, y, and z. And the question is now, what is the output?
What we totally forgot to mention is that we can write any C code in C++ and it will compile, it will work, so it's backward compatible. We can, of course, do this. So you can use anything that you have learned in C, also in C++, but in some cases it makes more sense to use the C++ specific functionalities.
So if you use pointers, for example, they just work similar as in C.
Yeah. Okay, maybe 10 more seconds, and then we can take a look at the answer.
Great.
Nice. So
at least the majority has it right, but some of you thought that the output would be 269, but why is this not the case?
let's go through it briefly. So we pass x, the value of x actually, so 2 to this function here. We increase the value, it's 3 in this function here, but it remains 2 in our main function. So
this is called by value, so the value is copied, and then the original x is unchanged, so 2 is the first value in the output.
Exactly, yeah. And I think what we wanted to do here is we want to use the concept call by reference. So we pass a reference of y to the increment function, but okay. Yeah,
this is the tricky part, maybe. So
in this line here, we are not actually increasing the value of pointer, so we are not increasing 5 to 6, but what we do is we increase the pointer by the size of the integer pointer here. So we point to the next 8 bytes and we don't increase the value. So that's why it remains 5 here as well.
So it would have changed to 6 if we first would have dereferenced the pointer and then with plus plus we would have changed y. But in this case we just increased the pointer, the variable of the pointer, so the value of the pointer, the address that it stores, and we do not change the value of y.
Where it points to, yeah.
Yeah, where it points to.
And yeah, now for the set variable, we pass the reference here, and we don't need to dereference it anymore. This would have been required if it is a pointer, but since this is a reference, we can just use it like this, increase it by 1, and yeah, in the end, this will result to 9, and in general, this will be 2, 5, and 9. All right, so we have now included the references, and the next, again, today, only cool features of C++, nice concept in C++ is function overloading. First, let's go a step back to C. If we would have wanted to write 2 functions with the same name in C, like this, do you think this would have worked? So, any idea if this works, if this will lead to some error? What is the behavior of this function, of this program? Any ideas? Does this work in C? Yes? No? Okay? Exactly. It will give you a compiler error. It will say, okay, the function func was already defined. You cannot redefine it. So what we can now take away from this program here is that C uses the function name to identify the function, and only the function name. So this is important here. If we now want to do the same thing in C++, so having 2 functions, one with 1 parameter, one without a parameter, do you think this will work in C++? Yes. No, it will not work.
Yes.
Yes, it will work. It will work.
It will. Maybe you've spotted the output already.
Okay, yeah. That's true. Yeah, in C++ this works, and this is extremely useful because now you can have multiple functions with the same name, but what has to be different is the parameter types, or actually the parameters. So you can have the same function without a parameter, with a parameter. You can have the same function with multiple parameters and also with different data types of the parameters. So it's not only identified by the function name anymore, but also by the parameters, so the types and the amount of parameters. And yeah, this is quite useful in C++. Together with that, we can also have default parameters. Again, very useful if you have a list of parameters and you don't expect the calling code to fill all the parameters, and you just assume if this parameter is not passed to the function, you will just take a default value. This is very helpful, so you can now call a function without all parameters. In this case here, you just have to pass parameter 1, otherwise it will not work. And if you want to, you can also pass parameter 2 and any other optional parameters. if you want to. But it's important here that the parameters that have a default value can only be at the very end of the parameter list. So you cannot start, for example, here with a parameter that has a default value, then having one parameter that has no default value, so that is required to pass to the function, and then again have a parameter with a default value, and so on. So all the parameters that have a default value, they have to be at the end of the parameter list of this function. Otherwise, this will not work. The compiler will not allow you to write such a function.
Yeah. This is a pretty useful concept that is available in C++ and also in many other programming languages.
Yeah, absolutely. We can also see this here in the example. Let's take this function call here first. We can call the function add with the two parameters here. First parameter a is 5, b is then also 5. This will return 5 plus 5, which is 10 for the second function call. And now maybe more interesting, the first function call, we only pass one value, even though we have two parameters here. But since the second parameter has a default value, it is not required to pass this parameter. And if the parameter is not passed to this function, the function will just assume that b is 10, and 5 plus 10 will then result in 15. So quite helpful. Of course, we can not only have one default parameter, but we can also have multiple, in this case 2 default parameters. We can also have 10 of them, and yeah, they all follow the same principle. We can pass them if we want to, but we don't have to, and the function will just take the default value.
And as we can see on here, we can also just pass a few values for the default parameters. So in this case, we pass a value for a, and for the default parameter p, this is overwritten with the value 5, but c stays with the default value.
But if you just want to pass the values for a and c, we would have to write all 3 parameters. So we cannot just skip one default parameter in between, but we have to write every parameter if we, for example, want to pass a value for the last parameter. So here the order of parameters is very important. Any questions to function overloading and default parameters? Yes? Sorry? Can you define parameters as null? Can we define parameters as null? Of course, we could do that, yeah. In this case, I don't know if it would make sense, but in general, of course, you can do this, yeah. Yes, there's another question.
Can you use a parameter and then half of another parameter as an input? For example, b equals a times 2 in the figure.
So the question is if we can use, for example, the value of this parameter, or actually this parameter here, in when calculating another default value of a parameter. To be honest, I've never tried this out. I think this would be super helpful, but I'm not sure if this works.
Does not work.
It does not work.
Just tried it out, doesn't work.
Because I think the compiler doesn't know at compile and then also at runtime what should be taken here into account, because there's not really a memory address, for example, for the variable here, a here, and would be super helpful, but unfortunately does not work. Any other questions? Yes.
Does the happens if you have two functions with identical names and one of them has two parameters with one default value and the other one has only one parameter, and you call the function with only one parameter?
That's actually also a very good question. So what happens if we have two functions, one with one parameter, one with one parameter and a default parameter? I would assume it will take the function without the default parameter. Maybe we can...
So, if I got it right, so we have two functions with the same name, with the same amount of parameters, with the same data type, except that one parameter is a default parameter.
One function with two parameters and
Yes, one default.
and the other one with just one parameter.
Okay.
So we have a different amount of parameters, but
I would assume that the one with one parameter is then used. Yeah. So,
but these are really edge cases,
Yes.
but quite interesting. I will definitely try that. So,
okay.
yeah. But yeah, I would also assume it will take the function with just one parameter without the default parameter. All right. Then something that we might already know are enums, and in C++, of course, we also have enums. We have already seen them before when we introduced the namespaces. And in C++, we have this plain enums, let's call it like that, where we just write enum without type def, so that's nice, and with the states, with the values here. We can just use them. It's like we did in C. But C++ also offers the option to use enum classes. There are a few advantages of using enum classes. For example, it's quite similar to namespaces, but you always have to use the class, the enum class name here before you can access the state, the value of one of these enum class values. We don't do this here, so if there again is a naming clash, this would be quite bad when using only the enums, but with enum classes we can usually avoid this naming conflict. And also enums, so plain enums, translate to integer values here. So we already know this from C. And enum classes don't do that. So they remain the actual finished value for this enum class. And this does not translate anymore to an integer value. And this is also quite useful sometimes when we don't want to compare integers, but actually the enum class values. So very brief topic, but quite useful here. All right.
Yeah, the next topic is, I think one of the most advantages in C++ compared to C that we introduce you today. So it's dynamic arrays or vectors in C++. And the question is, what annoys you at arrays in C? And I think there are many things. So we just highlighted a few. So the first thing is we cannot change the size. So if we have an array in C, we say we define the size and then we cannot change the size afterwards, which is in some cases bad because we want to sometimes enlarge or shrink an array and then we would have to create a new one and copy the stuff and so on. So this is a disadvantage for sure for arrays in C. The next thing is no bounds checking. So as you remember in C, if we have an array and we exceed our valid range of indices, then we access memory that does not belong to the array anymore and we could get in trouble then.
Yeah, so we simply don't know what will happen when we access some location that we should not access. So it would be nice to have some defined behavior if we access something out of bounds, for example.
The next thing is that in C, we must know the size of the array at creation time. So we always have to think how large should the array be. And yeah, this is a decision that has to be at creation time. The next thing is there's no real copy mechanism. So if I want to copy arrays, or as I mentioned before, enlarge or shrink arrays, I always have to do some copying manually. The next thing is I also do not have length information. So if I have an array in C, I always have to remember the length of the array. So I have to maybe, store it in a separate integer variable, for example, or whatever. But there's no length information that I get out of the array itself. And if I want to implement a dynamic size array in C, this for sure would need a lot of implementation and is hard to implement. And now coming back to C++, there is such a tool that is called vector, and this is also in the std namespace. Std vector is a resizable array that can store multiple elements of the same data type. So for example, we first have to include the vector library that we can use then vectors. And in our first example, we create such a vector. We say that we want to store integer items within this vector. So we specify the data type within these brackets, then a name for the vector, and optionally followed by, for example, this list of integers that are then stored within the vector. And then this vector is created with the size 3 and with those integer values 1 to 3 stored inside. And afterwards, I can use member functions of this vector library. For example, v.size gives me the actual size of the vector. So in our case, it would be 3. The next thing is I could extend it by adding values with the pushback member function. For example, adding the value 4 and then printing the size again. Now it's 4. So this shows the dynamically enlarging and shrinking vector in this case. And then we can for sure also access the elements at index 0, for example, with the add member function. This delivers us the first element, which is 1 in this case, as we can see in the output. And this add function is a better way to access compared to what we have known from C, where we use the square brackets, where we could then get out of bounds somehow. In this case, if we would get out of bounds and access it, for example, at index 10, which is obviously not a valid index here, then the program would terminate, which is a better way than having undefined behavior for sure. And how we can handle this at runtime, this is something for a later lecture within our course, but at least we know if we get out of bounds, the program terminates.
Always, yeah. We know that it will always terminate, so that's really helpful here.
Okay, and now coming back to the for each loop again, which we can now use for vectors here. So if we want to iterate over the whole vector, we can now use the previously introduced for each loop. And in this case, also a nice example where we can use auto. Because in this case, we use our vector, and at each iteration, the first and the second and the third and then the fourth element is stored in the variable element from data type auto. In this case means integer for sure. So in this case, it's no problem using auto because it's completely clear. We are iterating over our vector, which is storing integer variables. So this is totally fine using this this way. Okay, so this is now a second example using a vector. In this case, we use a float as data type, and then we can store float values within the vector. So we can not only create, but also initialize it at once, as we have also seen in our previous example. Again, the add function is doing bounds checks. So if we are out of bounds, program terminates. And pushback, we have also seen before, is to add elements at the end, and the size function returns us the actual size of the vector. And for sure, there are many member functions more. So for this reason, we have here this link to the C++ reference where you can read through the documentation and check all the other useful functions that vector comes along with.
Yeah, I think we will introduce some of them in the upcoming lectures and also in the practicals. But yeah, these are the very basic and probably the most important functions.
Mm-hmm. Okay, and then we come to the next Slido quiz. So we again have a code snippet for you, and the question is again, what is the output? So here we have again a main function and another function that is called addElement. In the main function, we create a vector of integers with some elements. Then we call the addElement function passing our vector. Then we call pushback within the addElement function, and then in the main function back again we use the range-based for loop with auto, as we've seen before, to iterate over the vector and print element by element. Another question is, what is the output?
Let's wait another 20 seconds and then we will see what is actually printed.
Okay.
A lot of discussions going on. Let's see. Nice.
Okay.
Wow.
Yeah.
To be honest, I didn't expect that.
Again, most of you got it right, but yeah, almost 40% thought it would be 1, 2, 3, 4. But it is not that obvious because there is an issue within this code. Maybe, just remember the concepts that we have introduced today so far. There was one concept that we introduced, which was called references, to avoid call by value. And this would be useful here to use references to avoid this call by value. So maybe we can go step by step through it.
So we have to change one small thing. We'll see that. Now the vector that we pass to addElement in the main function is copied. So this is a call by value function call. So we copy the vector with all of its elements to another variable here in the addElement function, and
from now on, so I'm sorry, from now on in our memory we have two different vectors. And in this add element function, we are working with this one vector, but back in the main then, we have our original unchanged vector. Because it was called by value, it was copied.
But it's actually a completely different vector that we have passed to the add element function. And yeah, since we modify the vector in add element, these changes are not reflected in this vector that is used in the main function here. That's why the output is 1, 2, 3, and 4 is not part of this vector here.
There's just one character missing to have the call by reference solution without copying, and this is this reference here.
So just adding the symbol here will not copy the value of the vector, but you will have a reference here of the vector, and every change here in add element is then also reflected in the original or in the actual vector in the main function.
So now in our memory, we just have only one vector. 2 names for it. So in the main it's v, in add element it's vec, but it's just one vector in the memory. And then changing it for sure affects also the main function.
All right, yes.
In C++, no arrays, only vectors, or other forms?
You can of course use, so the question is, are there also arrays in C++ or are there only vectors? Since we've mentioned before, you can write any C code also in C++. You can, of course, use arrays in C++. That's totally fine. But vectors are just much more convenient and comfortable to use. So I would definitely, in most of the cases, recommend vectors. Yeah.
When you use a normal array, do you also have to use the reference?
So the question is, if we would have a typical array we know from C, for example, if we would also have to use the reference, and yes, of course, we can do this, we should do this, then we have again a second variable, just with a different name, it's just an alias, but both of them have the same value.
But in most cases, a vector would be more convenient. So in most cases, you will use vectors. And also, I think this is also in the slide, in most cases, you will also want to use references. So in most cases, you don't want to have a call by value to always copy the whole vector and work with another vector. So in most cases, you just want to pass the vector, so to speak, using a reference and work on just this one vector.
Yeah, so it's definitely more efficient, also more memory efficient. Okay, this brings us to the last topic of today's lecture, which are strings, and you probably already know strings from C. But in C++, we have another data type for this, and this is called std string. Again, let's take a step back to C, and let's take a look at this code snippet here, where we want to concatenate 2 strings into one string. In C, we can do this using a function provided in the string.h header. There's a function called struct. We can pass 2 strings here, and we can print the concatenated string. This is totally fine. It works, but we always have to take care that the, in this case, first string has enough space to additionally store the second string. So we always have to be careful if there is enough space to store both strings and concatenate them properly. It works, it's okay. But if we take a look at another example in in C, when comparing strings, this doesn't look that beautiful.
Yeah. You have to write a lot of code to compare 2 strings in C. So then you have to do some checks and so on. You have to work with the pointers.
Yeah, a lot of pointer arithmetic.
Yes.
It's not that straightforward.
It gets better in C++.
Exactly.
I promise.
Because in C++, strings or the std string data type is actually just a wrapper around the C strings. So the character pointers that we have used in C. But the cool thing, so similar to vectors, is that STD strings have a dynamic size. So you can just add a character, add another string, remove some parts of the string. So it has a dynamic size that's quite useful, and you don't have to worry about the size, about the length of the string. Also, yeah, that's also very useful or helpful here is that you don't need to manage the memory anymore by yourself. So related to the size, you don't have to take care, is there enough space for example, adding another string or removing something. This is all managed by the STD string. And similar to vectors again, we have a lot of predefined functions to perform some operations on strings. We will see them on the next slides. And you don't have to implement any or most of the functions by yourself anymore. This is most of it done by the STD string library. Okay, let's take a look at some selected functions of STD string. Okay, the creation and the initialization is quite similar to C strings, so do character pointer strings. We just have a different data type here. When we want to access elements, we don't need to use the brackets anymore. So again, similar to vectors, we can just use the function at and at the index here. And similar to vectors, again, we have a bounce check. So if we access an element that is outside of the string of the actual array of characters, we will get some defined behavior and the program will crash. For getting the size or the length of the string, we can use size or length. Both will return the same value. They're just here for being compatible with, for example, the STL containers, but doesn't matter for the moment. You can use both of them to get the size of the length of the string. And if there's any need to work with the actual C string that is used underneath, you can also call the function C_str, and this will return the C string, so the C array, including the null byte and so on, and you can then work with that if you need it and do some operations that you would have done, for example, in C, but most of the time you will just use the STD string. But there might be some use cases where the C string is needed.
Yeah. Now coming back to what we've seen before in C, which is concatenating strings and then comparing strings. And now we can see in C++ it's much easier because we can just use the plus operator to concatenate strings. So we have str and str2 for two strings that we have defined and initialized, and then we can just concatenate them by using the plus operator and store it, for example, in the first string, and then, for example, printing the first string. Yeah, we can see that the output is the concatenation of both strings.
And also comparing strings is now really straightforward. We do not need this large amount of code anymore for comparing two strings. We can just use the is_equal operator here, and this will tell you if the content of the string is the same or if it is not the same. So when we remember when we were doing this in C, we compared actually the memory addresses of the two variables, and now we can compare the actual content of these two variables. So that's a huge advantage as well. We have also a lot of different functions for string manipulation. We'll go through them quite quickly. So we can clear the string or the contents of a string using the clear function. There's also a pushback, similar to vectors, where we can add another array, another character. Then there's also the append function, which is used to not only append one character, but another string at the end of the existing string. There's also a function for finding a string, so we can pass a substring or just a string to find if this is located somewhere in the string. If this is located in the string, we will get the position of this substring, and if the substring is not part of the actual string, we will get STD string npos, which means not found. It is the largest maximum possible value for a position in a string. So
yeah, but we can now use npos for comparing or checking whether we found the substring within the string or not.
Exactly. So we can just use this value here. So STD string npos. And an example here is that we want to find p1 in the string hello OOP1, and this will return 9. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So the position of the substring p9 is 9, and this is what is returned by the find function. We can also cut strings, so this is quite similar approach. We pass two size t variables here, or size t values, and the first one means the start from which it should be cut, and then the length until it should be cut. Again, let's take a look at an example here. So we have the start position 7, 1, 2, 3, 4, 5, 6, 7, so just before OOP1, and then 1, 2, 3, so the length is 3, and we only cut out this part here, so OOP. Yeah. Everything else is removed here.
First parameter is the index and the start index, and the second one is the length of the substring.
Exactly, and we also have a code snippet here that combines the find and the substring functions. I think for the sake of time, we will briefly go through this here. So we have the find function for the underline, and we want to replace the underline, or we want to split Tom and Turbo by the underline, then have a substring for the first part, so for Tom, and for the second part for Turbo, and then we just print it. So it's quite straightforward to use this.
Just an example for find and substring combined together. Yeah, straightforward.
All right, and we have one final quiz here. So the last few minutes. We have the first string, this is, and then we have the second string, which concatenates the first string and Sparta. Then we access the element at position 0 and assign k to this element at position 0. We perform a substring operation, so we cut a specific part out from this whole string, and then we just print the string. Another 10 seconds. Again, lots
of discussions again, yeah. Maybe there are some issues within this code.
Let's see.
Okay. Oh. this is Sparta, just 26% got it right. But what is the problem here?
Why is this the case?
Yeah, now it is on top, okay.
So let's take a look at this.
So just give us two minutes, please.
And then we are done for today, but this is the final example here. We want to show you why this is Sparta is printed and actually not what we would expect, which would be either TH
Yes.
or maybe even something with K. So when we assign this value here to str_add, this is stored here. This is totally fine, and this does not modify str_2 anymore. So yeah, it just modifies the first string, but doesn't modify the second string. But the problem in this code snippet here is that we do not assign the value that is returned by substring. So when we take a look at the function definition, this will return a std string, which is a substring of what we have called. So we call this function with str_2, which is in this case, this is Sparta. We pass the parameters 0 and 2, so we would cut out these two characters.
TH.
And this is then returned by the function substring, but we do not store.
We do not do anything with this value, with this new string. We do not store it, so the original string 2 is unchanged in this case. So we just compute a new substring, but we do not store it. So if we then print string 2, this is Sparta. But if we want to have it stored, overwritten, then we just have to assign it, as we can see here.
And that's why if you want to use the modified string, we have to store it somewhere. In this case, we can store it here at string 2. We could also define another string, for example, std string str_3, and then print this string. So we have to take care of the returned value of these functions. All right, so this was I would say, intense introduction to C++. A lot of content. So remember that every C code also works in C++, but we have a lot of new or additional improvements, concepts that we can now use in C++. We've talked about the references, the range-based loops, auto, which is quite useful, also function overloading and default parameters, and the nice data types, vectors, and strings.
Yeah.
We'll cover more the next time.
Remember that next week there is no practicals, but a double lecture where we then continue with classes, and then the week afterwards we have the first practicals.
All right.
Thank you so far, and see you next week.
Thank you for being here. Have a nice evening.